makes sense. Okay, so today I'm going to call this 9.2. We're going to look at an extension, and we're going to kind of try to tie back to the text that I traditionally use. But I do think that even just a couple weeks of doing it, I have a better ability just right away to start doing a little bit more discovery stuff, even with the book that I have. Like, I can try to implement it. It's not going to be as nice and drawn out, or we'll see. Anyway, if you don't have this in your notes, please have it. Our whole goal, just so you know, and some of you already have it, I'm going to keep talking at you. We've seen matrices so far, and already two, or at least one big situation where it makes things super duper fast. The area of a parallelogram on the plane isn't a super duper hard problem, but it's kind of tedious if you're doing it with the algebra. It takes 5 to 15 minutes, depending once you're comfortable with it. How long does it take you to find the area of a parallelogram if you're using matrices? Like 30 seconds, maybe. It's so fast and so efficient. If you were a computer, which, I mean, you are, right? We're all just meat computers. That is a much easier calculation and less cognitively taxing, so less brain power, than if you just use a determinant. Now, I don't love mathematics being just plug and chug, and that's the fine line here between whether you're a computer scientist learning this or a mathematician. We get some really, really valuable shortcuts that maybe we don't understand why they work, other than the fact that they do work. So that's just the nature of matrix stuff in general. For the notes, I'm going to erase B and C, or at least move them for a moment, because I want us to work problem A, and then problem B, and then problem C, and that'll leave us with a pretty natural spot, I imagine, to end class today, where we'll see it, application of these things tomorrow. Okay, so I'm going to move these out of the way, and I'll have to grab them in a minute. But if I want to find AB, I think I can do that. Is that different than BA? Definitely, because commutativity with multiplication does not happen with matrices. So first challenge, or not challenge, first problem, I guess, is with your neighbor, if you haven't done so yet, or if you have done so, and I've checked it, I want you to see if your neighbors need help or assistance or clarification. I want you to actually find AB. So when we take this matrix A, 1, -3, -4, 1, and we multiply it by this matrix B, xy, it is going to give us a product. Cool. Do this multiplication for me. Yep, so if the middle pieces, if they match, it's like they fall out, and our new matrix will be 2 by 1. Your second entries, these ones. Okay, just erase the ones and erase that second column. Okay, open to whoever wants to volunteer. I'm just going to write a couple extra things. Abigail, what's the dimensions of this matrix? 2 by 2. Cool, I agree. Kalisha, what are the dimensions of this matrix B? How many things?
1 by 2.
How many?
1.
Okay, so you've hit all 3 of the options. Which one are we going with?
Wait, 2 by 1.
Good. 2 rows by 1 column. If these middle parts match, which they do, I know that when I multiply these, my new answer is going to be a matrix. And what are the new dimensions? 2 by 1. So help me figure out what they are real quick, or what it is, rather. There's only 1 column to multiply by, so nothing crazy happens. Can I just tell you what I get, and you check? Okay, when I multiply these, 1 times x is x, plus -3 times y would be plus a -3y. I'm just going to call it minus 3y. Okay, there's my first row. That looks like it's separated, Kalisha. It's not. That's my top part. So I know that my answer is going to be 2 rows, 1 column. It's just 1 times x plus y times -3. But instead of saying plus a -3y, I'm just going to say minus 3y. I was yellow, not orange. Goodness. Peach? I don't know. All right. How about the other one? Negative 4x plus y. All right. This is the one thing that is, in my opinion, the most frustrating for me personally about matrix stuff, is there's something about this that just bugs the heck out of me. And it doesn't change right or wrong. Where this equal sign sets up just in my natural writing and where it shows up in a matrix drives me crazy. And I do it wrong every time. If you look at anything that I ever do with matrices, you'll see I erase it every time because no matter how many times I make that and it bugs me, I do it every time. Okay, so that's AB. I'm good with this so far. Okay, that was question A. That was just a review of the multiplication stuff. Any questions, concerns, thoughts, compliments? Oh, burned. Okay. Looking at it, let's knock out B then. Okay, I want, and this is, it's pretty subtle and there's not a whole lot of stuff to it, but I shouldn't have erased that one. I'm physically or literally asking you just write down what your answers give us. So it means that we should get a new matrix AB, which we have, right? We get this lovely matrix x minus 3y and negative 4x plus y. And allegedly, that's AB, right? Not allegedly, we just found that that was AB. This is equal to what? I need to move. Negative 13, 8. And I know it seems strange, but there's a connection that's about to be made, I think. So I gave you, Felicia, at the very beginning, great question. How did I do that? Can you be a little bit more? Okay. Is it a system?
No, not like, is 13 part of 13 and 8? Is it part of the system?
Well, I think so, but let's dig in a little bit more. This matrix can be misleading. AB, its product. What are the dimensions of this?
It's 2 by 1.
It's a 2 by 1, even though we have these, right? So if I claim that this matrix is equal to this matrix, also a 2 by 1, I think I'm pretty confident to say that x minus 3y better be equal to what? Negative 13. Better be true that negative 4x plus y is equal to 8. And I can see that Sean's suggestion, and Fern, you were close to this on your first statement. I think that if I ask you, what does this represent? And I hate the way that it's going to organize itself just on my screen, not anything else about it. The way that we see these, if I say, what does this represent? This whole piece on B. Well, this is just a way to write a system with matrices. Do you guys agree with this? Just a system of 2 equations and 2 variables using a 2 by 2. And that nice that it all fits together. This is a way to represent a system, and I'm not changing colors because I'm already committed. A system as a matrix equation is what I'm going to specifically say. Okay. Now, for this next piece, could you solve that system of equations using substitution or elimination? Like, not in the general sense, but could you personally just thumbs up, yep, I can do this, no problem, I'm super confident. Thumbs down, I might struggle. Or I, go ahead.
Multiplication. Sorry, I didn't hear you.
Could you solve the system that's represented by x minus 3y equals 13 and negative 4x plus y equals 8?
To figure out what the values are?
Yeah, for x and y. Using substitution or elimination. And you might have to check notes. My hope is that you don't, but it's been a while since we've done this, so I totally get it. Cool. If we want to be really explicit with it, the matrix equation, or the matrix stuff that we see, really gives us a system x minus 3y equals what again? Negative 13. And negative 4x plus y equals 8. Now, ever since, I'm not going to use those brackets because that makes it look like a matrix. I'm not going to do that. Terrible choice. We'll use that. Okay. At one point in time, and I don't even remember if it's this class or physics, somebody's comment was seeing a bunch of different ways to do a problem can be misleading. And I get it. I agree with you completely. However, there are 2 fundamentally different ways that we can solve this problem, just like we have substitution and elimination, and they're both answering the same thing, but they're different, right? Okay. Just like that, if we get a matrix or a system of equations that's represented as a matrix, there is a way to solve this that's going to work out in a couple different options. There's a way that I think intuitively we'll be okay with. I think it'll make sense. There's another way that's much faster, way faster, that we'll look at tomorrow, I think. But we're going to see two options that are doing the same thing, and I'll probably ask you to do each of them separately to demonstrate for me that you know you can do this. But I'm not trying to confuse you. I just want you to see two very different feeling and looking problems that are answering the same thing. Cool. All right. Now, looking at this, we are going to use matrix equations. That's going to be our first part. And I know I use the language a little bit, but we're going to see it in action now. And we're going to keep solving this system of equations is what we're going to do. But I want to think out a little bit of the intuition and how it's going to work. So our first section is solving systems, or solve systems, with matrix equations. Question, Huggins?
I just got it wrong, I think.
Which part?
I skipped ahead. I don't even know if I'm supposed to do this. I'm doing that.
So you're trying to solve the system?
Yeah.
You don't erase it, just leave it. We're gonna check it out with matrices. I'm gonna do it the old way using substitution or elimination, and we're gonna compare it with what you guys get. But I wanna make sense of what's going on. If we are given these matrices, and I'm just gonna keep referring back to these for a minute. This matrix right here that I'm putting inside this box, how does that matrix relate to the system of equations that we're dealing with? And I can scroll down so we can see it. How does this matrix relate to this system?
It's the like coefficients are all standard.
Oh, I love that language. What we have here in front of us, this AB in this situation, this is what we're going to call a coefficient matrix. So we'll sneak that in quickly as a definition. Solving systems with matrix equations, we are going to get a coefficient matrix. And I can give us a formal definition if you'd like. It's a matrix made of what? I don't want to write it down if you guys are cool with not writing it down. Cool. And we multiplied it by something. So here's AB, right? Coefficients, that's where we got them. What is this? It's not a coefficient matrix. And I don't know that there's a formal word that we're going to use, but how would you describe what that matrix is? X? Kind of. Do you know that like X and Y, they both change, right? Constantly, that's what they do. I'm trying to use, there's a better word, but I don't want to use it. It's my variable matrix. Cool, I'm good with it. Now, whether or not that's a formal word that you would learn in a matrix class, I don't think so, to be honest, but I'm okay with thinking about this. This is the variable matrix. And when we put them together, and we're just using our own language right now. We're not adding jargon to it. The coefficient matrix, that was awesome that you said that right off the bat. That's the true name of it. What do we call these? And what would you like to call them? The 13 and the 8. They're clearly the answers, right? But they're not really the answers to the system. They're just what each equation is equal to. I'm going to call this, these are always going to be numbers, right? Does this number change? So for lack of better language right now, without going, I'm going to call these constants, or my constant matrix. Understanding that we are making a clear distinction between a coefficient, which is connected to a variable, and a constant that an equation is equal to. Have I lost anybody yet? All right. So here's what I want us to think about. If I had coefficient matrix, and I can add these numbers, and that's all fine and dandy, but I'm going to write my letters first. Let's say that just for now, without drawing the actual matrix, we'll call this A. And this is what we did above. That was A. We'll call this one B again. And we'll call this one C. Bless you. Now, when we have these, if we want to solve a system of equations, what am I really looking for? Like the answer to this system that we created on part C above. what if you find the answer using substitution elimination, what is the answer representing? So eventually we wind up with x equals and y equals, right? Everybody comfortable and you're good with that. In the end we get x equals and y equals. Now, here's my claim. I know that this thing b that we already wrote above is of this form, and I'm just going to write underneath of it. It is an x and it is a y. Okay, everybody all right with that? Like, that's exactly what I did. Now, the constant matrix even, I also know its numbers were negative 13 and 8. And I'm just plugging in things, and I know that we did this above, but there's a reason and a justification for why I'm holding off on this. Here's my thought. If I could get to just this point, and it would be different numbers, like if this were, and I don't know the answer, I haven't done it yet, but if this were a 4 and this were a 5, and somehow I got everything else to fall off, if I had a 4 written right here where that 13 is, do you agree that it's literally telling me that, oh, x is 4? Or right now, it's not complete, but right now, if this is all that we had ever, it would tell me x is negative 13 and y is 8. And that's just a different way to write an ordered pair using our matrix stuff. Okay, here's the kicker. Instead of writing that coefficient matrix with all the numbers, I'm going to hold off for 1 second, and I'm going to call this A, with the understanding that it was a matrix. Now, the fact that I've waited so long to do that, I hope is going to make this connection a little bit easier. If I only wanted to have x and y in that matrix, matrix B, if I only wanted that on the left side, so that it's equal to something on the right side, that would solve the question. If only, bless you, I could undo a matrix A. Now, in regular stuff, I see that A times B, you normally undo it by dividing, right? Have we divided matrices? Huh. So if we can't divide it to get only x and y on that side, we need to use another tool. Oh, goodness. Say that louder. An inverse would undo it, right? And it would make it the identity, which if you multiplied it out, you would get just xy. Here's what I want you to do for your assignment tonight. Algebraically, this works the same. If I do something to the left, I have to do it to the right, yeah? To solve this on the left, and we have to pay really careful attention since commutativity doesn't work with multiplication. On the very left of this, what did you say is going to undo matrix A? I'm going to take A inverse and multiply it by A. Where did I do it? Which means if I multiplied on the left side by A inverse there, on this side of the equation, where should I multiply by A inverse? On the left. We are going to stay consistent. Your homework tonight is one problem, but there's 2 parts. Find me A inverse, and then multiply it by A, and then xy. Find A inverse, you've already done it, and multiply it by this. See if this solves your system. I'm going to check in your notes tomorrow, okay? Solve this. Find A inverse, multiply it. I'm going to make a note so I don't forget to check it in your notes, because that happens like 50% of the time.
Scary.